All right, hello again and welcome, guys, to G Squared Academy, where you know excellence is epitomized. Now, today we are looking at ionization energy and its trend in the periodic table. So, the first thing, let us kind of loosely define ionization energy. So, basically, if I have an element E, right, the ionization energies the amount of energy required for this electron, let me just erase that bit, to lose an electron. For this element to lose an electron, that's what we're going to loosely define ionization energy as. We know that when we look at energetics, right, we will define it in more specific terms in terms of gaseous conditions and more standard conditions, etc. But we're just loosely defining it here so we can understand the trend. So, what's the trend in the periodic table? Going down the group in the periodic table, the ionization energy decreases. And the reason for that, the electrons are further away from the nucleus. There's a lot of shielding going on between those electrons and the nucleus. So you have these barriers between the electron and the nucleus over here. And so, therefore, what happens is that the ionization energy decreases because it's easier to remove this one electron with all that shielding. When you go across the period now, the ionization energy tends to increase. Why does that happen? Because you're adding electrons to one shell, right? And you're making this nucleus more positive every time. Even though you're adding electrons over here, the electrons have a weaker or less influence on the size of the atom and the nuclear charge. And so, therefore, it becomes more and more difficult to remove the electrons as you go across the period when they're being added to that one shell. All right. So even though as you go across the period, you're expecting a general increase in the ionization energy, right? There are some anomalies. And this graph that you're seeing on the screen here will help us to understand those anomalies. So here on the y-axis, x-axis rather, you have the atomic number or the proton number, and over here you have energy. You can clearly see that there's a general increase. But moving from 3 to 4, you have that increase, but then from 4 to 5, you have a drop, then an increase, then a drop, right, from 7 to 8, and then increase 8 to 9, and then an increase 9 to 10. And the question is, what your examiner loves to ask is, why is there a drop from 4 to 5 and from 7 to 8? So I will now explain that. Okay, so in the first instant, what we have is beryllium 1s2, 2s2, and then a drop to boron 1s2, 2s2, 2p1. Now, that can be explained with the fact that this p orbital is a little bit further away from the nucleus than the electrons in the s orbital here. So that's one explanation. Another way you can look at it is that this is a less than half filled p orbital. Remember that there are three p orbitals, and in this p orbital there's only one electron. It's less than half filled and it's not filled. And the rule and the standard that we're working with is that a half filled or a filled orbital is more stable than a less than half filled or a little bit greater than half filled orbital. Okay, and so this will explain why this one electron is so unstable in this region, and therefore the ionization energy drops a little bit. In the case of nitrogen, over here, nitrogen and oxygen, 7 and 8, notice that the electronic configuration of nitrogen is 1s2, 2s2, 2p3. And this is what the p orbitals look like for that, half filled. Really, in the case of oxygen, you have 1s2, 2s2, 2p4. So what you have now is that you have an additional electron in this area. And this additional electron has caused such great inter-electron repulsion that it is very easily lost from the valence shell of the oxygen atom. And so, therefore, the ionization energy of oxygen would be lower than that of nitrogen because of the increased inter-electron repulsion that occurs in the oxygen atom, right? And so it will lose the electron more easily because of that. All right. And so this trend is pretty similar to period 3 as well in the other periods. I hope you find this helpful, and I wish you all the best.